Hello everyone, and welcome to another audio podcast in this series around the pathology storm. This is the as part of the Shientist Chartered Edition, and today's audio podcast will be about the immunology and the complement system. In and around and surrounding COVID-19. This is a Storm Robotics production in collaboration with the Renal Patient Support Group, the RPSG, and I am your host, the Shientist. So, immunobiology and the complement system. So, upon recognition of SARS-CoV-2, complement system becomes active and promotes pathogen response through what are known as lectins, and the alternative pathway. The numerous anaphylatoxins, like complement C3a and complement C5a, bind to specific receptors, leading to stimulation of histamine, leukotrienes, and prostaglandins, which results in flushing, hypoxia, vasodilation, and hypotension. Additionally, an activated alternative pathway generates a C5b B9 or beta 9 in tubules apical brush border as a response to the virus, leading to over-accumulation and tubulointerstitial damage. The disruption of lymphocytes and the role in the maintenance of immune hemostasis leads to lymphopenia, which has been identified and observed in patients with severe COVID-19 symptoms. As those cells contain ACE2 receptors, SARS-CoV-2 might target them, reducing the number of CD4 and CD8 T cells. This results in an unequal distribution of immune response, hyperactivation of the innate immune system, and a long process of terminating the virus. Another factor of lymphopenia might be reduced inflammatory responses, which prompts lymphocytes apoptosis, leading to lymphocyte ratio disproportion. Through analyses, patients with severe COVID-19 have expressed injury around the spleen and lymph nodes, which suggests that virus can damage lymphatic organs, reducing contribution to immune hemostasis. There may be some overlap between immune responses after detection of a foreign pathogen, facilitating hypercoagulability. Initially, however, circulating pro-inflammatory chemicals activate blood monocytes. Endothelial cells are activated by cytokines and virus particles, which create adhesion molecules and monocyte attractants, leading to the recruitment of activated monocytes to endothelial cells. Endothelial cells also use neutrophils, which conduct coagulation contact pathway by realizing neutrophil extracellular traps, which activate platelets. Additionally, tissue factors might be exposed due to any endothelial damage. The blood viscosity increases as levels of oxygen decrease due to hypoxia induced by COVID-19, leading to stimulation of thrombosis. So in this section of the peer review manuscript, there is an illustration that highlights the presentation of complement system's possible contribution to inflammatory response in severe COVID-19. Following that, thrombosis laboratory indexes like partial thromboplastin time, prothrombin time, and international normalized ratio are elevated, and D-dimer, which correlates with high mortality rate in COVID-19 patients. Additionally, peripheral blood smears express low fibrinogen level and thrombocytopenia with schistocytes under morphology. Several factors may prompt microthromby and microangiopathy, which elevate the risk of microinfarctions across cardiovascular, respiratory, and renal physiological systems, inducing irreversible damage where COVID-19 symptoms are present. Understanding around rhabdomyolysis is also important because it is caused by a muscle breakdown arising from numerous factors such as overexertion, trauma, toxic substances, or healthcare complications over time. Autopsy data of COVID-19 patients present acute proximal tubular damage and glomerular fibrin thrombi with ischemic collapse. There are several theories in the literature that suggest viral induced that suggest or are suggestive of viral induced rhabdomyolysis. It might be induced by rhabdomyolysis may be induced by the cytokine storm as well, damaging muscles, circulating toxins, muscle degeneration, or direct virus invasion. Due to the novelty of COVID-19, there is little transparency between a correlation surrounding rhabdomyolysis and acute kidney injury in symptomatic COVID-19 patients. So the next audio podcast will look at an overview of organ crosstalk and biomedical communication. This ends this audio podcast around the immunobiology and the complement system. This has been the Shientist in this series around the pathology storm, part of the Shientist Chartered Edition. It's been a Storm Lobostics production in collaboration with the Renal Patient Support Group, the RPSG. Thank you for tuning in.